So how to Elmer's order now. Here's a part that I would like Elmer's to laser cut and bend for me. This is supposed to be the top of a fuel tank made out of aluminum. So the first thing that Elmer's wants from us for submission is a drawing. Obviously, we're also needing DXFs to actually get the parts cut on the laser table. So the whole point of this drawing is so it can basically cross-check that you have the right dimensions in your DXF for the actual flat pattern and for checking any bend callouts that you have if your part is bent, obviously. But yeah, just basically for cross-referencing. So the main goal of the drawing is to have the overall dimensions of the part for them to check. It's wise to kind of keep your dimensions nice and centralized, or not, basically not all over the place. So instead of having this width call out here, instead of having it all the way up here, I'd put it down there, just so that, same thing with the thickness, just so everything's relatively close together. So if your part is bent from sheet metal, you will typically have a view layout like this, where you have the flat pattern in the top left, and then your the cross, I guess the side view of the flat pattern, which is just flat, obviously. But that's just to reference the thickness of the part. Notice that the dimension for the thickness is the only one in 3 decimal places and in brackets. Obviously change your decimal point when you edit the dimension, and then you can add brackets with this little button here. The brackets is basically saying that it's a reference dimension. You can use that those brackets on any dimension that is just for reference. So if you're, like, let's say you have these bends already defined in one way, but you want to call them out in a different way for whatever reason, just for clarity, then you can have a dimension in a different view that also defines it, but in brackets, so it's not sort of over constraining. All the rest of your dimensions, apart from your bend radius, I'll get to that in a second, should obviously be in 2 decimal places. The more decimal places you add, the more cost goes up. Reason being is that Elmer's follows a basic, or a standard, tolerancing standard. Seems to be ISO 2768 of the medium variety, at least from the documentation that they've provided us. Obviously, that documentation is pretty much all you need to actually know how to make a drawing, but there's more I'm going to go over on the specifics of what we do for actually submitting. So the other thing is obviously getting your bends called out. So when you first make a flat pattern view in SOLIDWORKS, it should actually make those callouts for you, which is nice. I do have these in 3 decimal places. Only reason being is because the bend dies they use are typically in some kind of fractional inch step. So like they'll have a 16-inch radius die, an 1/8-inch radius die, and so on. So I just made it 3 decimal places so that, like, 063 is obviously 16th inch, so it's a little more obvious. It might actually show up if you were to make this as 2 decimal places. The way you change that is by going into System Options, or Document Properties, and then going into Tables here, this little drop down, and then going to the bend, I guess, menu, and then you can select how many decimal places the document will automatically put in for you, whether it be your angular decimal places or what have you. So I've got my bends called out for where they should be relative to an edge. One option for me here would have been to use an ordinate dimension to say I want the first bend 3/4 inch away from this edge, then the next one to be 6.72 from the same edge, and then however far away this final bend is from this edge. But what I care more about is actually how uh, long this flange is on the end, so I didn't use an ordinate dimension. Another option for me potentially would have been to use a center line to call out symmetry about the axis, which is valid. You'll see that in some of their sample drawings they do that, but for clarity's sake, since I have a bend right in the middle on that center line, I just wanted to make sure that they don't misinterpret that somehow or miss the symmetry call out. But yeah, if this didn't have a bend here, I would totally use that and just have the 1 3/4 inch call out here, and then this would be basically redundant on that side. So that's all for your views. If you're doing a flat part, it becomes a lot more simple. All they want is basically the width of the flat pattern and the height of the flat pattern, and then obviously the thickness called out. And I think there's examples that you can see for what those actually look like, so I won't go over that. But what else you do need to do, especially for a bent sheet metal part that is an isometric view, is super helpful for them to actually make sure that they've bent it properly. Obviously you have your ups and downs for this. Oh, and one thing I forgot to go over is how to actually get these bend callouts in a more convenient place. So you can actually choose to have a leader on the callout, and then I like this one that kind of underlines it, and then you can drag it wherever you want, and it points to the bend line. As I said, yeah, isometric view just for them to make sure they made it properly. Interior features like holes or cutouts like that doesn't really matter, just because it is getting laser cut at the end of the day, and the overall dimensions are what they're going to be referencing to make sure that DXF is proper. Other thing you need to do is add a small note that just says it's laser cut, as well as obviously make sure that your part number as well as your section and team is in the correct naming convention, obviously. And if this was the 5th part that I was making for the powertrain section, then obviously I would name it 005. But since it's the first one, it'll be 001. And then our revision, obviously this is the first drawing of this part that I'm submitting to Elmer, so I'll make it revision A. If there's an error with the drawing or some reason that we have to send it back to them, then we'll have to have a revision notes sort of addition onto the drawing. Usually that gets added either to like the top or the side of this main box here, or one of the corners. I'm not actually sure where it would go on this particular sheet format, but the goal is to not have to use it in the first place. So other thing you need to add is obviously make sure that you're saying that it's in inches, as well as saying that it's per ISO 2768-M for the tolerancing spec, and then obviously the thickness and alloy of material that you're using. So 14 gauge is 0.064, and for aluminum at least. Steel it would be different, of course. And then of course your weight. Make sure you have your weight, because that's another way that they make sure that what they're making is actually the size you want. Just as another quick tip, if you're needing to use a custom drawing template like this, then obviously when you're going to make a new drawing, it's not going to show up if it's just something you've just downloaded. So the way you do that is obviously you just click Browse, and say if it's got sent to your downloads or whatever, then it'll be this SLD DRT file type, and you would just open that, and then it'll get selected, and I believe there would be an option to like have that folder in your computer be a reference for it to actually automatically show up in this main list here, so you don't have to keep going browse every time. Okay, when it comes to actually making the DXF for the part, biggest thing number one is to make sure that you are in inch, pound, or inches, whatever other units, doesn't really matter. For weight on the drawing, they want pounds, I believe, but make sure your model is in inches because that will affect what units that your DXF is saving in, and if you're in the wrong, like if you're in millimeters, for instance, your part's going to be 25.4 times smaller than what you want. So we are going to save this part as a DXF, and we want to call it the same thing as what the part number is on the drawing. So the drawing should also have the same have the same file name as this DXF. So F-PT-001 is what's on our drawing, so that's what we are going to save it as. And if it's a bent part like this, the best thing to do is have sheet metal selected as the export type, and then make sure that the bend lines is clicked if you have a bent part. Then once you click OK, I configured SOLIDWORKS. Don't ask me how, but I found out how to get this menu to show up if it doesn't already show up for you. But it's important to have because then you can have hidden lines for your bend lines. And this is also critical to have if your part is bent, is to have these little gray lines showing where the bend center line should be for the brake operators to have on hand. So obviously the white lines is what the laser is going to trace, and then the bend lines are just a sort of a digital reference. I don't actually know how they use it, but apparently it helps them, so make sure that you have your bend lines in your DXF. So that should be saved. God knows where it is now. So I have my DXF file saved here. Now the biggest thing is that if I open this in eDrawing Office, which is kind of the generic SOLIDWORKS program that it opens DXFs with just to view them, when we open the DXF up, we will see that there is a watermark saying this, and it is obviously white, so that means the laser cutter will actually trace that. So we can't delete it in the generic viewer that SOLIDWORKS gives us, so what we have to do is download AutoCAD. We get that for free, by the way, so make sure you go onto AutoCAD Student Access download site or whatever, and then we will open the DXF in there to delete that. Okay, so now we're in AutoCAD, and now we can actually click on these and tell them to go away. Just press delete, and then they disappear, and obviously you can see our bend lines are still a different trace than our cutouts, so that's good. The coordinate system, you can ignore that, that's all good. Then we want to save it as a DXF. Make sure that you don't save it as a DWG, because that, for whatever reason, it loves to make that the default file save, but really make sure that you're saving a DXF, because we've had issues with that in the past. And keep the same file name, of course, just replace what you already have. And now, should be able to wait another 7 billion years for this even simpler software to open.
6.5 hours later.
Now we can see that our DXF does not have the watermark, so this is ready for Elmer's submission. If you really want to be careful, you can just go into the measure down here and click on any line and make sure that it is in fact 13.44 inches and not whatever divided or multiplied by 25.4.